Hi, today we're going to talk about lesson 2 vectors. We've been dealing with a lot of vectors, especially in the kinematics unit. Everything has a direction and a length. And when we're solving any problems that are involving vectors, some of the vectors that we have been talking about or we will be talking about are things like displacement, velocity, forces. Like these are commonly used vectors that we could possibly be using the vector method, because like if I have an object traveling east and then north, we can't just add the two numbers together and find the total. So what do we need to do is we need to consider the directions. And today we're going to talk about two main methods. The first one is the algebraic method. Sometimes we're required to use SOHCAHTOA or sine law and cosine law, or we can actually use the component methods as well. For each vector, we can break them into the xy component and do the summary. And that's what we're going to be talking about today. So first of all, vectors are always represented by arrows. And we have the length that is considered to be a magnitude. Like say, for example, 5 meters. That's the length. And then the directions, we use a special chosen coordinated system. And say, for example, north 30 degrees east. So usually what this means is if I have a coordinates and we assume the north, east, south, and west in the common way that we use to write it, if we say something that is a north 30 degrees east, what it means is starting from the north, like if I have starting from the north direction, this is horrible. All right, let me see if I can do a straight line. I'm sorry. Okay, so if I have something that is going towards the north, this is north, and if I have north 30 degrees east, what that means is from the north, I'm going to swing towards the east direction at 30 degree, and when I measure that out, the vector would turn out to be right here. So that's going to be the new vector that we're going to be talking about. Do you see how it's going north 30 east, meaning from north swing towards the east direction? And so that's why they're telling you that, you know what, you can also write it as east 60 north, because if this is 30 degree, this is a supplementary angle, meaning this bottom angle has to be 60, meaning from the east direction. If this is going east, I have to swing east towards the north direction. So that's why this is east towards the north by how many degree? By 60 degree. Okay, so those are the two commonly used one that we are going to be using. Okay, the next thing we want to talk about is the tip to tail methods. Whenever we're adding vectors, we're basically putting the tail of one of the vector at the tip of another vector. So if I travel north, and then if I travel east again, I will keep going from where I ended and go east. And to figure out what the overall is, we would go from right here. We would go from the starting point towards the ending point and having the tip and the tail all connected together. So this question, v1 and v2. v1 is the red vector. v2, I'm not going to actually do measurement or anything. So basically all we're going to be doing is we're going to be trying to kind of get the main point. So every time when you're drawing a vector diagram, it's always good to have a big dot. That's your starting point, because it's important that we know that we're always measuring or finding our resultant vector from the starting point to the ending point. So the starting point is important. So I always put a big dot to represent it. Okay, so v1 plus v2, meaning I draw v1 first. This is just an approximation. I label my site. Okay, and then if I do v2, I would now start right here where I ended, and then I draw my v2, whatever the second vector is. Whenever I'm adding, it's almost like saying you just keep going. You don't go back to the starting point. Wherever you left off with, you keep going. Okay, and then the resultant vector, it's always from the starting point to ending point. So from where I started, I draw a line towards the ending point, and the resultant vector is v1 plus v2. Next one, how about v2 plus v1? I will still repeat the same process. I would always put a dot to represent my starting point. I do my little axes here. Okay, I would go V2 starting here is going down towards the southeast direction. And then drawing V1 now, V1 is the red vector. I will continue going where I ended off with, and I would draw an approximation of vector. So this is V1. I forgot to label V2. So V2 plus V1 is like that. And so what does my resultant look like? Starting point to ending point. V2 plus V1, I always label my vectors. Other things you should always watch out for is, do you see the arrows that I put in every single one of them? So make sure you remember when it's a vector, you draw an arrow. Okay, so why do I do V1 plus V2 or V2 plus V1? What I wanted you to know is when you're adding, the order doesn't matter. Just like if I go 2 plus 5 and 5 plus 2, you should end up with the same number. When I'm adding vectors, you should end up with the same, because if you look at the final vector for this question, if I go back to the last slide, the V1 plus V2, I know it's not exactly perfect, but those two should give you the same vectors. Okay, and then finally, what's V1 plus V2 plus V3? So starting point again, I'm just going to start out with, so I have my starting point, V1, okay, and then V2, I'm going to keep drawing from where I ended up. Oops, that's really bad. Let's do it again. Okay, it was slightly shorter, kind of down that way. Okay, V3, I'm going to keep going. So I'm going to be a green vector. And this time, I am going to keep going from where I ended. And I draw my V3. So what's my final answer? What is the actual answer? It is starting point to ending point like this. So this vector is V1 plus V2 plus V3. And this kind of demonstrates, when we go back to the definitions of positions or something like that, it really doesn't matter in between what the trip is. We only care about the starting point to the ending point. And now this is something new. We haven't done this in grade 11. How about if I'm asking you to subtract a vector? Okay, the rule for subtraction, you know how to add. The example we've done here, these are called adding vectors. Do you see that plus sign there? When I'm adding vector, I just draw one after another, right? So you know how to draw adding. So they're suggesting to you that when you're subtracting the vector, the easiest way to do that is, it's like you're adding the negative of the vector. Okay, so if you see the equation, V2 minus V1, it's the same thing as V2 adding. Remember how when I add a vector, I just keep drawing. But the only thing that's tricky is that I actually keep drawing the negative of the vector. So let's do the example. Okay, so V2 and V1, so I'm just going to change this pen. We said that whenever we do subtraction, we wanted to do the addition of the negative. Okay, so V1 is the red vector, and the negative of a V1, it's going to be the same vector. See how the same length, but opposite. This is negative V1. Okay, so then we're just going to repeat the process like we did. When I'm drawing V2, I draw my starting point. I draw my little dot. I go V2 first, so I'm going to draw something right here. This is my V2. I am adding it, meaning I'm going to keep drawing from where I ended up. That's adding vector. Remember, we did it for the previous 3 examples. We keep going, but this time I'm not going to draw my original. I'm not going to draw my original V1, but I'm going to draw the negative of the V1. Okay, so instead of going up straight up like that, I'm not going to do that. I'm actually going to draw going towards the southwest direction. It becomes like this. When you actually take algebra, they will be talking about how do you do a parallelogram method, but I'm not going to get into that. So I need you to keep in mind to know what is subtracting vector. It's adding the negative. Okay, so when I'm adding the negatives, I draw my vector like this, and this is my V2 minus V1 vector. Now we're going to continue talking about the different methods that we're going to be solving problems. In grade 11, we did this thing called the scale diagram. We would literally draw it with the correct length and use a protractor and measure to an angle. In grade 12, unfortunately, we're not going to be doing this at all, okay? There are two other methods that we would use. The second method is called the algebraic method. You would still be required to make a sketch. Okay, you do want your sketch to be semi to scale so that you can always check your answers, and then you actually use algebra to calculate the resultant. And depending on what types of triangles are given, if it's a right angle triangle, you can use the Pythagorean theorem or the SOHCAHTOA. And for any triangle, including right angle triangle, you're always allowed to use the cosine law and the sine law. And the general rules to decide which law to use is if I have a triangle, if I know the two sides, so if the two of the length are known, as well as the angle in between the length, this is usually when we use the cosine law. Sine law, on the other hand, is if I have a triangle and I happens to have the angle and the corresponding length that is directly across from it. If I have a known pair, then that's when I would use the sine law relationship. So an example here says that you have a canoeist who travels 12 kilometers south, 30 degrees west, and then he traveled 8 kilometers per west. Calculate resultant displacement. So the first step you would do is you would list out your vector. These are displacement. Displacement is delta d with a vector sign at the top. And there's two displacements, so I'm going to call this delta d1 is 12 kilometers south, 30 degrees west. And then it keeps going with the second displacement, so we're going to call it delta d2 at 8.0 kilometers west. These are vector picture that does not involve acceleration, so you don't have to convert it to the SI unit. The next thing that you would need to do is you're going to have to draw a vector diagram, okay? I always like to do a dot as a beginning, okay? I would always just start out with the dot, so I know that's my starting point. And I do a little compass here. Okay, this object goes south 30 degrees west, meaning going from the south direction, it's going to swing towards the west direction for 30 degrees. Okay, so I'm going to draw a vector that is going south 30 degrees west. So this angle right here is 30. So touching the south, it is going at 30. So the 30 degrees is here, and the length for this vector is 12.0 kilometers. Okay, after the first vector, I ended at this point. At the end of the trip, I am at that point. I keep going to the west, so you can actually redraw the little crosshair thing, and I go directly to the west. This is 8, so I'm going to draw it slightly shorter than the 12. Just try to, you don't have to use a ruler and actually measure the length, but I would definitely suggest you draw it so that it looks at least semi-proportion to what you're doing. Okay, and then now I'm going to do my starting point to ending point. I'm drawing my resultant. Starting point is the red dot. I'm going to start from the red dot, and I'm going to draw a resultant vector towards the end of it. So I'm just going to, these are vector diagrams, so please make sure you put your directions here. And this is called the delta D. I'm just going to call this delta dr for the resultant displacement. Okay, after your picture is drawn, now you can use your algebraic method. This is not a right angle triangle, so I am not allowed to use SOHCAHTOA and Pythagorean theorem. So let's take a look at what we have. I have 30 degrees, and it's not inside the triangle. I need to figure out the angle inside the triangle, and there are many different ways for you to figure it out. I'm not sure if you're seeing that. I'm just going to totally jump ahead, and I'm going to tell you that this angle right here is 90 plus 30. Are you seeing that? Are you seeing that this is 120 degrees? Okay, many different ways, as I said, you could be figuring this out. Okay, so the first one is use the parallel line theorem. Okay, I'm going to scribble all over the place right now using a highlighter. You don't have to do that. I'm going to make this a bit skinnier. Okay, I need you to see that this is a north and south. I'm going to add this. This is a north and south. This is also a north and south, meaning those two lines are parallel to each other. Okay, and then I have an angle 30 here. The parallel line brings us Z pattern. This also becomes 30. Are you seeing that? And then at the same time, I have a right angle at the bottom left here. So it becomes 90 plus 30. That's why the angle inside that triangle, it's 120. I'm going to undo this. And I'm going to show you another way that you can look at it. Okay, I'm going to still use a highlighter. I'm going to use yellow this time. Okay, this is 30. If I drop this line down, and if I draw this, complete a right angle triangle, do you see that I have a 90 degree and a 30 degree at the top? So that means if I use the angle sum of triangle theorem, 180 is going to equals to 90 plus 30 plus whatever that other angle is. Okay, so this has to be 60. Do you see that? Okay, if that's 60, and if this is a straight line, okay, according to the supplementary angle theorem, the straight line have to add to 180. So 180 minus 60, making the angle inside the triangle also has to be 120. Okay, so whatever ways you want to look at this is fine. You're using either a triangle theorem or whatever other parallel like geometry theorem. There are many different ways that you can solve this. So now I've established that this is 120 degrees. Now I can study the triangle. Okay, so right now what do I have? With this triangle, I have the length of 8 and a length of 12. So I know the two sides, and I also know the angle in between the sides. So what that means is I'm allowed to use the cosine law. So in here, I'm going to use my cosine law. Okay, so delta dr squared is going to equals to 12 squared plus 8 squared minus 2 times 12 times 8 times the cosine of 120. Okay, this is the part that I'm going to ask you to pause if you need. Punch it in the calculator. Work out what delta dr is. Okay, since we're using trigonometry, I just wanted to just double check and make sure that you check the setting on your calculator. There is this little guy here on top. I don't know what calculator you have, so you gotta have to check. Sometimes it's a single letter that says D, R, or G. Okay, see this one here? It says R-A-D, and this one says D-E-G. Okay, whenever you're doing trig, just a friendly reminder, it should be in the degree mode, so either a D or it should be in D-E-G. Okay, if it's in this setting, R-A-D, that is not right. You're in the radian mode. You will not be able to get the same answer. So just double check the setting. Okay, so now I'm going back to here. I'm going to use my calculator. I double check that is in degree mode. Most of the time it should be in degree mode. If you're taking calculus, some of your settings that you would be required to use, you would have changed it to radian, and that would totally change your answer. So sometimes it's easy to miss this little thing. Just double check, because during a test or something like that, when you don't get to check your answer, sometimes you just wouldn't know. Okay, so punch everything in the calculator, take the square root. So I got something like a 17.43559, things like that. Okay, so delta dr worked out to be 17.4. I'm going to keep two significant digits, right? So I'm going to write 17 kilometers. I'm not done yet. This is 3 marks, okay? So if you check the success criteria, we're just going to draw it anyway. Okay, I'm going to use this thing. You get 1 mark for the diagram, okay? If you miss arrows and stuff, you would lose half a mark if you're missing arrows. Okay, and then you would get 1 mark for writing out the equation, the cosine law, 1 mark for getting the correct answers, and this is 3, but the whole question is out of 5. Because this is vector, it's a displacement, you also need to find the directions. Okay, so you're required to find what is the directions. So take a look at this. The direction you're trying to tell is the red line. Okay, the red line delta dr is where you're trying to find the direction. So if I take a look at how do I do this, I'm going to use an orange color. The easiest way to do is starting from the south, figuring out how big this angle is. Okay, how far from the south is it going to swing towards the west? So I'm going to write the general direction southwest. Obviously, I need to work out what the angle is. So how do I find the angle? Do you see how initially it has 30? So I know that to find the angle, it's going to be 30 degree, adding to whatever this angle is, which I do not know yet. I'm going to say that this is angle theta. And how do I find angle theta is I need to use my triangle, and we're just going to need to solve for that. Okay, so let's see how we do that. So right now, I have angle theta is what I like to solve. And I have 120. See how I have the angle, but I also already found dr, right? I have the pair of relationship that I have a known pair of angle side, which is opposite to each other. I don't know how to delete it. Okay, so let's start solving for that. Okay, I know sine of 120 divided by delta dr. Instead of using 17, I'm actually going to use whatever is stored in my calculator. I need you to get used to knowing the ANS. I don't know if you can find this button on your calculator. The ANS button. See right here? That one. Or this one. Or this one. Is whatever answer is stored in your calculator. Okay? So use the ANS button. Then you don't even have to repunch it. You just use whatever answer I got stored in the calculator is what I'm going to use. And so in this case, it's 17 point blah, 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 blah. Okay, it's going to equal just a sine law. So I need the angle at the top, sine of theta. And if this is theta, then you need to look for the side that is opposite to the theta, which is the 8. So divided by the 8 kilometers, you cross multiply. And for those people who really understand how to do cross multiply, you don't have to rewrite it out. You always find the pair that have both of the numbers. So 8 times sine of 120 divided by 17.4 or divided by the ANS button equals. And then you go second sine because you actually want the angle theta of it. Okay, I'm going to show the step at this point. I just want to make sure everybody's good. So I'm doing cross multiplying. So I have 8 times sine of 120 equal 17.43 times sine of theta. To get sine theta on its own, then you need to divide both sides by the 17. So to punch it in the calculator, see these two cancel. 8 times sine of 120 divided by ANS, whatever that was stored on your calculator. Okay, and then since sine theta equals to this, to get the theta on its own, you're going to have to go the second sine, which is like the negative of it. And the answer should work out to be 23 degrees. You always round the angles to the nearest degree. Okay, so it's not south 23 west. Don't forget to add it to the 30, right? So it's south 53 degrees to the west because I need to go 30 plus the 23. That's how I actually get the final directions. Now the next part that we're going to talk about is going to be the component method. So another method to figure out the vectors. First thing you need to know is how to find an x and y component of a vector. So example here. We have 65 north, 50 east. Do my little crosshair. From north, it's going to swing towards the east direction for 55. I'm going to draw my vector here. This length, the vector, is 65. this angle is 55. Notice that your vector is always going to be the hypotenuse of this right angle triangle that we're going to try to make. So this is always the hypotenuse. So I'm just going to write the H. We are always going to be making the X and the Y components. See how angle 55 is here? So it makes sense to wrap it around. So this is your Y component. And this is your X component. Okay, this is your X. And this is your Y. So with the right angle triangle, if I have an angle here, I'm just going to do the little studying here at the bottom. So I have a triangle. I know this is 65, which is my hypotenuse. I know angle theta is 55. If I would like to solve for this side right here, that is to the left, if I wanted to solve for this side, okay, this side, we're gonna, because this is a right angle triangle, we purposely made it so that it becomes a right angle triangle. I'm allowed to use SOHCAHTOA. I have my hypotenuse. If this is angle theta, and I have this side that is adjacent. If I have adjacent and hypotenuse, I use the cosine. So this is cosine of 55 is equal to adjacent over hypotenuse, which is 65. So the adjacent is going to be 65 times cos of 55. We good? So this is 65 cosine of 55. If I want anything that is opposite, so if this is the side that I want, this is now the opposite side. Okay, opposite and hypotenuse is my sine. So sine of 55 is opposite, which is what I'm solving for, over the hypotenuse, which is 65. Rearrange the equation for opposite. It's going to be 65 times sine of 55. So the rule of thumb is whatever my vector is, okay? So I'm just going to do my vector. I'm going to say my vector hypotenuse is here. And if I say this is angle theta, to find the component, the general rules are, if I want the opposite, it's going to be the hypotenuse times the sine, because opposite goes with the sine of theta. If I want the adjacent, which is right here, if I ever want to calculate the adjacent goes with the cosine, so it's always the hypotenuse times the cos of the theta. So this is kind of the little rule of thumb to help you figure it out quickly. Okay, so the bottom one is the proof of using just trigonometry. Hopefully you remember that. Okay, all right, so let's try the 95. Okay, 95 west, 17 south. So drawing my vector, west, 17 south. So touching the west direction, this angle is 17. And when you closed off the triangle, you always wrap it around the angle. You would not be drawing it down here. You could, but you're going to have to find that angle. So there's no point to just do more work than you need. So I got 17, so I'm going to wrap my triangle around to the west and then to the south. This is also the other hint for you, right? West and south. Okay, so this is 95 meters per second. So if I work on the one that is at the top, the horizontal one, that is the adjacent. Okay, since this is the adjacent, I'm going to look at, it's going to be the hypotenuse times the cos of theta. So hypotenuse times the cos of 17. You don't even need to punch it out. I'm not even going to work it out right now because you do the sum all at the end. Okay, and then the side that is going south is the opposite. So opposite would be the hypotenuse. So opposite would be hypotenuse times the sine. Hypotenuse times the sine of 17. Why is that important? If I go back to, say, the example C from like way back, if I want to use the algebraic method, you need to figure out the first triangle by adding v1 to v2, figure out what the final vector is, and then recalculate it for v3. So you're going to have to go through cosine law, sine law, cosine law, sine law, two times to figure it out. But one way to look at it is, if you break them into components, what you can do is you can actually figure out what is the sum. All right, so I'm going to show you how we do that. I'm just going to change the line style to a dotted line. Okay, if I take a look at V1, V1 really is the sum of a y adding an x. Okay, then vector 2 is then x and then a y. And then vector 3 is going directly to the right, so it only has an x. So those are all the vectors that I have. Okay, if I'm able to use component very easily, like, hypotenuse, cos, or hypotenuse, sine, and if I gather them all together, let's take a look at all the things that are going along the x. Okay, so I'm just going to take this guy. This is the x component of V1. This is the x component of V2. And this is the x component of V3. Okay, at the same time, I'm adding this up, and then the object travel up north and then back down to the south. Okay, and if I actually now take a look at starting point to ending point, I started here and I traveled to the ending point where the end of blue is. Do you see how it actually sums it up? And it actually became the resultant of it, right? So what that means is, as long as I gather everything that is along x and I gather everything along the y, then I can just do two vectors, the x and the y, and find out what is the overall resultant. And that's where the component method comes in. Okay, the rule for components, I suggest doing a chart. I'll show you how we would do that. Okay, you would find the xy component for each of the vector, and then you sum up the component along the x and the y, and then you finally use the Pythagorean theorem. Okay, so this method, I personally find the algebraic methods a bit easier if there's two vectors, but anything more than two vectors, if you have 3 or 4, it's probably faster if you do the component methods. All right, so let's go through an example. Find the resultant displacement for Peter, who traveled first 50 meters east 30 south, 28 meters north 55 east, and 17 meters west 20 degrees. I usually like to create a chart, and I would label the two axes, so going along y, the north and south axes, and then going east and west, the left, the x direction. And I often like to set up that north and east are positive, so that I know every time I'm traveling up towards the north direction, I'm adding it. But if something's traveling south, I'm going to have to subtract it overall. We'll show you what it is when we get to the example. So the first one that the first vector is 50.0 meters east, 30 degrees south. Okay, east, south. So draw your picture, east and south. So there's my picture. Going towards the east, going the south direction, this angle is 30. So if I complete the circle, the triangle, I go east and then towards the south. When it's east is a positive, when it's south is a negative. Notice I put my directions right away so I don't screw it up. Okay, so going north and south. So I'm looking at this side. North and south, it's directly opposite to the triangle. And when it's opposite, my component, the y component, is the hypotenuse, which is 50, sine of 30, because it is the opposite. So just now we established that when it's going opposite, we use the sign. I'm just going to write the 50 so we can write the hypotenuse right away. Okay, then going towards the east direction. East is the adjacent. Okay, when it's the adjacent, it is the cosine. So it's 50 times the cosine of 30. I'm not going to bother punching anything in until we get to all of the component. Okay, so that's the first vector. Second vector. Second vector is 28 meters north, 55 degrees east. North, east, so going north and east. North, 55 degrees east. This length is the hypotenuse, which is 28. And I'm going to go towards north, going to the east. I always just look at whatever they started out with. When it's north, I go up north, which is a plus, east, which is also a plus. Okay, dealing with the north and south. So north and south vector is the adjacent. So adjacent is the cosine. So 28 hypotenuse times the cosine of 55. Okay, the east and the west is the opposite to the 55 degrees. So when it's opposite, it is the sine. So hypotenuse times the sine of 55. And that's vector 2. Vector 3, it's 17 west, 20 degrees north. So going towards the west, going north. So going somewhere down here, west, 22 degrees north. This is 17 meters. So drawing my triangle, going west, which is a negative on the west side, and then going north, which is a positive going the north direction. So dealing with north and south, which is opposite to the 22. So this is opposite. And when something is opposite, I use the sine. So 17 meters sine of 22. And then the west direction is the adjacent to the 22. So that means I use the cosine. So I write the hypotenuse, cosine of 22. Okay, so now that you have kind of summarized everything that's going northeast, southwest, I can now, I'm running a little bit out of space. Hopefully you have a bit more space. I'm just going to draw my line. And I'm going to work now through the column. And I'm going to be, first of all, dealing, so using these three guys. Basically add them all onto the calculator, because that will sum up all the directions that are going south, and then back north, and then back north, to find out what is the overall effect. So I'm just going to add them all up. So negative 50 times sine of 30, adding 28 times cosine of 55, adding 17 times sine of 22. So along the y direction, I have a negative 2.57, meaning this is going 2.57. I'm just going to write a little bit more number here. Meters towards the south direction, because it is an overall of a south, of a negative answer. Okay. Then I'm going to sum up all the forces that are now going east and west. So I got these guys. By adding this column up, I have summed up all the forces that are going to the east and then travel back to the west. So I know overall horizontally how far I've traveled. So 50 times cos of 30, adding 28 times sine of 55, minus 17 times the cosine of 22. Sum them all up. I get 57. I'm just going to double check. So my answer, I punched it wrong. So the answer that I should get is 50. So 50.475. And because this is a positive, and we said that positive is east, is going to the east directions. Okay, so with these two that are done, now what we need to do is I'm going to have to now use the Pythagorean theorem and draw a triangle with a 2.57 going south and then a 50.48 going to the east, and then sum it all up. Okay, so I'm just gonna, this is the same question. I'm just gonna keep going. So I'm now gonna use my Pythagorean theorem. I'm gonna redraw my vector. So the first vector, it's going south. So I have a vector that is going south and is 2.57 to the meters. And then it traveled east at 50.48 meters, and draw my resultant starting point to ending point. This is now my overall displacement, and we call it the delta dr, just resultant displacement. Okay, so right angle triangle, I'm allowed to use my Pythagorean theorem. Okay, this is me, my stubbornness. I wouldn't use these numbers, but it's up to you. If you can't handle all digit, it's fine. But I would like to use all of the digit. Okay, take the root. The answer should work out to be 50.5. So I just punch it in the calculator. Take the square root. So the answer is 50.5. Check the sigdig. I have 3, 3, and 3. So 3 sigdig is what I'm keeping. The unit is in meters. And then, of course, don't forget to find the directions, okay? When we find the direction, we always find where the starting point is. So the angle theta at the top left corner is what I'm finding. And if that's the case, then 50 would be the opposite, and 2.57 will be the adjacent. So I'm going to use tangent. So tan of theta is 50.48 divided by 2.57. And then shift tangent, shift tangent of whatever answer you got. Angle theta should work out to be 87 degrees. So final answer is south, 87 degrees to the east. A car turns from a road into a parking lot into an available parking space. The car initial velocity is 4 meters per second east, 45 north. The car's velocity just before the driver decreases the speed is 4 meters per second east, 10 north. So this is your V1 and this is your V2. Then the turn takes 3 seconds. Calculate average acceleration of the car during the turn. So this is almost like a combination, because notice the direction changes, right? Like usually I don't know if you remember your high five. Or did I say you have to memorize your high five? Do you remember your acceleration equation? Is final minus initial over time, right? So normally on a regular kinematics equation, you almost look like, oh, I'm going to go 4 minus 4 equal divided by 3, and it's 0. But obviously this isn't the case. The reason for this is you actually need to take into account that they're vectors. I don't know if you remember, when it's vector adding or subtracting, you can't just add or subtract the numbers together when the direction has changed. So this is the part where you need to actually use algebraic to figure out what the actual change in the velocity, and then you plug it back in and divide it by a scalar quantity, which is the time. Okay, so this is a two-part question. First of all, you need to use vector diagram, figure out this is the one. Figure out what is the V2 minus V1 in terms of vector. And then after you get a single value of answer, then you go into your delta t. Okay, so I'm just going to erase this guy. Okay, let's do it all over again. Okay, so what am I given? Just be very careful. Okay, so my V1 is 4.0 meters per second east, 45 degrees north. And then V2, your final velocity is 4 east 10 degrees north. So this is like going in a circle. Okay, I don't know if you've ever heard. This is actually like, can you imagine it? You're going east 45, and then now you're going at east 10. Do you see there's turning involved? When there is a turning involved, we call these the centripetal acceleration. We will talk more when we get to like lesson 13. Okay, but now we're just gonna figure out how to first of all use this equation. I know that acceleration is delta v over delta t. I need to figure out what is delta v. So I actually need to figure out what is v2 minus v1 in terms of vector diagram. And from the lesson before, we talked about this. We haven't done vector subtraction before. What I need to do is I need to go v2 adding the negative of v1. So what is the negative of v1? Okay, negative v1 becomes the same value, so 4, but this time instead of east 45 north, it's west 45 south. That's the opposite. So it's like you east north, this is east north, you just swap it. Okay, so do you see how it's going southwest now? Okay. All right, then I follow the same triangle rules that we've been doing. We draw the first vector, adding, and then we draw the second vector. Okay, so the first vector is v2. v2 is east 10 north. I'm just going to draw a triangle here. Big dots, that's my starting point. So I'm drawing the first vector v2, east 10 north. So this is 4, this is 10 degrees, and this is 4 meters per second. Okay, then I'm going to draw the second vector. We'll cross here. But this time, the second vector, I'm drawing this guy. I'm not drawing my v1 anymore. I'm drawing my negative v1, which is west 45 south. So it's going to go this way, west 45 south. Same length. This is 45. And this is 4. All right. I am just going to change this up. See how my 4 is inside the triangle? It makes it really messy. So I'm just going to redraw this. The 4 is here. All right. Now to finish off the triangle, I have added the vector by just drawing one after another. Now to finish it, I have to go from starting point to ending point. Starting point is the dot that we have. And the ending point is this. This is my delta v. Okay, this is what I actually draw. I actually draw v2 minus v1. That's what I actually draw. Now using algebra, I need to solve the triangle. I need to find the angle inside the triangle. Okay. I am going to use this. See this 10 degrees here? It means the Z pattern. So right here, I'm going to use a highlighter. I use a small yellow highlighter. The Z pattern, see how the west and the east, that's a parallel line, right? And with the parallel line, I can go, okay, let's pick a more contrast color. I don't know, orange. Okay, no. Okay, Z pattern. No, let's just do big yellow. Okay, Z pattern. This is my Z pattern. The 10 and the 10. Okay. So what that means is I have found that this is also 10. You guys see that? I'm going to draw my Z pattern again with a thicker blue pen. Maybe not that thick. Let's do it. Okay, the Z pattern goes like this, like that, and like that. So the angle, this angle, and this angle are the same. That's why they're both 10. I'm going to undo it because it'll look really messy. You can pause the video if you need. So this is 10 and that's 45. Do you see this angle right there? That one is going to have to be a complementary angle theorem. So it's a 90 degree. It's within the east and the west, right? 90 degree minus 45 minus 10. So this angle is a 35. Okay, so now I got the angle inside the triangle. Two sides, and the angle inside the triangle, I use the cosine law. So delta V square If you don't remember your cosine law, you are required to know it. So please take the time and try to memorize it. Okay, then take the root of it. So I multiply everything in the calculator, take the root of it. The answer worked out to be 4.5. So delta V is 2.4. Why did I say 4.5? 2.4 meters per second. Okay, and I need the direction. So what direction do I need to find? Starting point to ending point, right? So I need to find this blue vector. I need to know what direction it is going. I need this angle. How do I find this angle? I couldn't just right away find it. I actually need to use the angle inside the triangle. I actually would need to find out what is this total angle is first. Okay, and then it becomes, so the angle should be east something towards the south. And to get it, it's going to be angle theta. Do you see how I have to minus the 10 degrees from the red? Minus the red 10 degrees. I'm going to do this in minus the 10 degrees. Because part of that angle is actually going towards the north direction. And I don't want that. I want to know the blue, the dark blue. Okay, so I need to calculate what is angle theta using the triangle and then subtract the 10. So let's work this out. So sine of angle theta over 4 is equals to sine of 35 divided by 2.4. Cross multiply, solve for your angle theta. So 4 times sine of 35 divided by 2.4 equal second sine of the angle. Angle theta worked out to be 73 degrees. So to finish it off, so this equals to 73 degrees. Subtract the original 10, which gives you the 63 degrees. So the actual direction is 63. From east traveling 63 towards the south directions. All right. You would think you're done. You're not done. There's one last part. You need to calculate for acceleration. You've only calculated the delta V. So to finish off the question, acceleration is change in velocity over time. The change in velocity which you calculated, okay, divided by the time, which is 3 seconds. So finally, you got the answer to be 0.80 meters per second square with the direction of east 63 degrees. Step. Super long and lengthy. 2 big parts. Do you know how to do vector subtractions? And then after you've done that, then you just divide it by a scalar, which is time, and it's still going to